All right, hi there. Today we are going to be looking at um, geometric sequences. And geometric sequences have a formula. It's a of n times r to the n minus 1. Each one of these things represents something. R represents the common ratio. I'll show you what that is in a few minutes. A of 1 is the first number in the sequence. N is the number term in the sequence. And a of n is the number in the sequence. And you can write that on your formula sheets, please. So now I'm going to show you how to use this formula. The first thing I'm going to do before I get to that formula is talk about geometric sequences. We did arithmetic sequences, let me write this down, a while ago. Arithmetic is where you're adding over and over again. Where you add or subtract over and over. Geometric is different. Geometric is where you multiply or divide over and over again to get the next number. Okay, so back to this. So I'm looking at this. Which are geometric sequences? Find the common ratio. So, I have to find the pattern here. Now, to go from 20 to 200, to go from 200 to 2,000, to go from 2,000 to 20,000, you'd figure out sooner or later that I'm multiplying by 10 each time. Okay, so since it's multiplying, it is geometric because you're multiplying or dividing over and over again. And the common ratio, the easiest way usually to do it is to take, the second number and divide it by the first number. So if I took 200 and divided by 20, that's 10. Now you could also have gotten that by, from this multiplying by 10 over and over again. That's another way you could have gotten it. But that's my common ratio. And you could have just said R equals 10. I'll know what that is, okay? All right, so that's the first one. Second one, how do you go from 2, 4, 6, 8, 10? Well, that's a pretty easy one where you're just adding 2 over and over again, which means this is not geometric, this is arithmetic, coming from the word arithmetic. And you're only finding the common ratio if there is if it's geometric. So this would have what's called the common difference. They're not asking about that. The common difference would be 2, that number you're adding over and over again. Or if you were subtracting over and over again, it would be negative, maybe negative 2. Anyway, they're not asking for that, but I figured I'd refresh your memory. All right, back to this one. So this one, this one's a little trickier. 5, negative 5, 5, negative 5, 5, negative 5. You could go about this a couple ways. If you want to tell whether something's geometric, if it doesn't jump at you, take the second number and divide it by the first number, and see what you get. Take the third number and divide it by the second number. Take the fourth number, divide it by the third number. They all should be the same thing if it's geometric. In this case, I'm getting negative 1 every time, which means, yes, it's geometric. And the common ratio is negative 1, or write the word common ratio. Okay, either one of those will get you the answer. Okay, next one. Question 2. Arithmetic, geometric, or neither? If geometric, find the common ratio. 3, 6, 12, 24, 48. To go from 3 to 6 to 6 to 12, that's times 2, times 2, times 2, which means it is geometric. And the common ratio is the same as 6 divided by 3, or 12 divided by 6, which is 2. 2 equals R. Okay. Next one. 1, 4, 9, 16, 25, 36. So this was trickier. You know, there's a couple ways you could have gotten this. You know, to go from 1 to 4, I'm adding 3. 4 to 9, I'm adding 4. 9 to 16, I'm adding 5. 16 to 25, I'm adding 7. Did I mess that up? I did. This should have been add 3, add 5, add 7, add 9. So clearly there's a pattern going on. However, this is not geometric at all. In fact, it's not arithmetic either. This is actually neither. All right, it's not arithmetic, it's not geometric. This should actually be neither. Because for it to be, I mean, it's adding, so you'd think it would be arithmetic, but you're not adding the same thing over and over again. You know, it's a 3 and then 5, then 7. So since it's not adding the same thing, it's not arithmetic at all. And C, 1/3, 1/9, 1/27, 1/81st. So there's definitely, you can kind of ignore the numerators for a minute because they're all 1. If I'm just looking at the denominators, 3, 9, 27, how do you get from there? Well, you're multiplying by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, which means if I'm going from, since it's just the denominators, you know, you're actually multiplying by 1/3 over and over again because I just want to multiply the denominators together, which means, and if you had doubts about that, you could have gone 1/9 divided by 1/3. And see what you get. Remember, to divide fractions, you flip and multiply. Which gives me 3/9, which is 1/3. Which would be the same thing as if I took 1/27 divided by 1/9. Anyway, geometric and common ratio is 1/3. Okay, next one. So here's where we're going to get into the formula. That formula I gave you in the beginning. This is one of the harder ones. Find the explicit formula for the sequence, then find the 15th number term. And the numbers are 10, 20, 40, 80. So the first thing I'm going to do is I need two things for this. I need R and I need A of 1. Okay. Remember, this is the formula over here. I'm going to write it down. A of n equals A of 1 times R to the n minus 1. Which means common ratio. How did you get from 10 to 20? How did you get from 20 to 40? How did you get from 40 to 80? And if you forgot, you could always go, 20 divided by 10, that's 2. 40 divided by 20 is 2, so on and so forth. So therefore, R is 2. A of 1 is the first number in the sequence, which in this case, that's your first number is 10. All right, so there's A of 1. And if I plug these numbers into the formula, I get A of n equals A of 1, which is 10 times 2 to the n minus 1. And that's the explicit formula. So once you've got that, you can find out anything you need. After that, because if I want to know, for example, their next thing they asked for was what's the 15th term. That means I'm going to plug in 15 for n. Okay, so if I do that over here, space 10 times 2 to the 15 minus 1, which means I get 10 times 2 to the 14th power. And if I type in 2 to the 14th power into my calculator, I get 16,384. Which means if I multiply that times 10, I get 163,840. And that would be the 15th term. Okay, that's about as hard as they get. Let me zoom out a little bit here. Next one, write an explicit formula for a geometric sequence with an initial value of 2 and a common ratio of 3. This one's much easier. All right, so if I take that formula, a of n equals a of 1 times r to the n minus 1, I get a of n. Okay, so let's see. Initial value of 2, common ratio of 3, which means a of 1 is 2, r is 3. I'm going to plug those two numbers in there, and I think I'm going to have my answer. 2 times 3 to the n minus 1. And that's it. They didn't ask for anything more. They didn't ask for what the 12th term is. I would have plugged in 12 for n then. That would have been it. Okay, next one. 5. What's an explicit formula for the geometric sequence 3, 12, 48, 192? All right, so this one's tougher. I'm going to go through the steps like as if I couldn't do this math in my head. 12 divided by 3, that's 4. 48 divided by 12, that's 4. 192 divided by 48, that's 4. Okay, so that means it is geometric. My common ratio is 4, and I need the first number in the sequence is a of 1, which is right there at 3. Which means my explicit formula is really like the equation, you know, is 3 times 4 to the n minus 1. That is all they asked for. Okay. So that is it. I'm going to close things out here. A little bit more Stevie Wonder playing on Sesame Street.
Ooh, very superstitious. Wash your face and hands. Give me all the problem. All that you can. Keep me at ease. Keep me going strong. You don't want to save me. I'll have to sing Sesame Street song.